Today, we're going to look at different coastal processes. But before we start with processes, let's look at a few terminology that we need to know. So the first thing that we need to know is the coast. Now, this is the area where land and sea meet. So this you would know as the beach. Next, we have the shoreline. And to understand the terminology shoreline, we need to understand the high water mark. Now, the sea level at the coast rises and falls during the day. When it rises up to a maximum point, that is called the high water mark. Now, if we have a low-lying coast, meaning a type of flat coast, that typical coast that makes the best beaches to have a tan session on, then the shoreline would be defined by the high water mark, so the maximum point that the water would reach during a day cycle. But if we have a steep sloping coast, maybe a coast that has a cliff or a coast with a dune, then the shoreline is defined by the base of the steeply sloping coast. Now, as the water rises to reach a maximum point and forming the high water mark, the water also falls up to a minimum point to form the low water mark. Now, the difference between these two is called the shore. So if we measure the distance between the low tide mark and the high water mark, we will call this area the shore. Now, the tides, which is the rising and falling of the water marks, usually happens twice a day, but it can differ from time of year as well from coast to coast. So if you go down to the coast for a holiday and you want to go do a hike on a very short shoreline, then you need to make sure about the tides during the day. Fishermen also check the tides during the day, and every day the tide will change. I know that in the Western Cape, for instance, the tide changes with about 45 minutes to an hour every day. So the high tide would shift by an hour every day. Now, where the shore was the horizontal difference between the low tide and the high tide mark, meaning the length between these two marks, the tidal range is the height or the vertical difference between the high tide and the low tide. Now, the different tides will determine the wave's height and depth, and the movement of these waves and the currents will affect different coastal features. So let's look at waves for a second. Now, the wind that's blowing across the sea surface will create the waves, which are marine processes which then erode and move and deposit material. It's the ocean's way of cleaning itself. Now, if any of you were lucky enough to ever have a marine aquarium, meaning a saltwater aquarium, you would have a piece of equipment called a skimmer, which would imitate the function of a wave. It would create these bubbles, and these bubbles after a while would get gross and murky and brown, sometimes even green. And that is because it removes certain debris from the water. Now, the size of the wave will be determined by three factors. Firstly, the speed of the wind, as well as the fetch, which is the distance that the wind traveled, and then also the amount of time that the wind blows in the same direction. Now, the size of the wave will increase as the wind speed, the strength, and the fetch increases. Let's have a look at a few examples. So here is a big wave. We can see that the wave is high, it curls, and it crashes. So the wind speed here would be big. As we can see, the waves in the background forming, even here at the back. This also shows that the distance that the wind traveled is pretty far because the waves already form far into the distance. Now, we can't from just a few seconds of a video see the amount of time that the wind blows in the same direction, but we can assume that it was quite for a while. Then we have this example. Here we can see that the waves are much smaller. This is because there is almost no wind present here. We can see this as there's no trees that are moving, no debris flying around. So the waves will be much smaller. Now the friction from the seabed would push the wave forward as it gets closer to the coast and into the shallow water. This is where it will finally crest and crash on the beach. Now the movement of water up the beach, this here is called the swash. And then the return movement is called the backwash. Okay, so let's define the types of waves that we get. And we get two types of waves. And I want you to first imagine this as a physics point of view. So we're going to draw them as two-dimensional physical waves. And the first wave would be a pretty big wave. So anyone here that has physics will recognize this type of wave. Now this wave has a steep wave gradient, meaning that the gradient from the lowest point of the wave to the highest point of the wave is pretty steep. It then also has a short wave length, meaning that the distance between 2 points that are in the same phase on the wave is short. It also has a high height and a high frequency wave rate. So the wave rate of this type of wave is usually between 10 and 12 waves per minute, meaning that this wave has a high energy. It's a very strong, abrasive wave, meaning that the backwash drags material out to the sea and forms shingle beaches. Now, a shingle beach, or also known as a cobble beach or a gravel beach, is usually a narrow beach that is composed of like coarse, loose, well-rounded and water-worn gravels. And this gravel is called shingle. Now, this type of wave is called a destructive wave, and we'll get to the name a bit later and why it's called that. Our second type of wave is then a smaller, flatter wave. So the first thing is that this wave would have a shallow gradient. So the gradient on the wave is much less steep than our destructive wave. This type of wave will also have a large wavelength or longer wavelength. This wave would also have a lower height, so it's not as high as the destructive wave, and it has a low frequency. So these waves usually happen at about 6 to 8 waves per minute. It has a low amount of energy, so it would have a stronger wash that would carry material up to the beach and then deposit a sandy beach. So this is the type of beach where you want to lay and have a tan on. This type of wave is called a constructive wave as it builds up beaches. Okay, so now we're going to have a look at these two types of waves from a visual perspective. So remember, our destructive wave is a big type of wave that has a steep wave gradient and a very high height. This type of wave will break down or destroy the beach with erosion. So it will dig into the beach and then deposit the particulates elsewhere inside the ocean, digging away at the beach and creating a more steep gradient in the beach and destroying the beach. Now, a constructive wave has a longer wavelength and a lower height. It's a smaller wave and it builds up beaches. So it constructs the beach by depositing from the ocean. So it will pick up particles inside the ocean and then deposit them on the beach. Now this is because of the wash and the backwash. A destructive wave will have a weak wash and a strong backwash. meaning that it will not deposit anything onto the beach, but rather take from the beach and take it away into the ocean. Whereas a constructive wave has a strong wash and a weak backwash, so it will deposit more onto the beach than take away from it. Destructive waves are able to erode beaches in different ways. So they can cut into the coastline in 4 ways: hydraulic action, attrition, corrosion, and abrasion. Now, the hydraulic action is a process where the force of the moving water erodes the sediment and the rock by exerting pressure on the cracks and the cavities. This will lead to the eventual breakup of the shoreline. We then have abrasion. Now, abrasion is also a type of erosion where the rocks and the sediment grind against each other. This will wear away the surface through friction, often caused by the water. So if we think about abrasion, the sediment is picked up by the water and then hauled against the side of the beach or the cliff, breaking the cliff away. Then we have attrition, and this refers to the process where rocks and sediment particles are transported by the waves. They then collide and break down into smaller, smoother, and more rounded pieces due to the friction and the impact. So we need to understand the difference between abrasion and attrition. Now, abrasion is when the rocks or other materials that are carried by the wave is then thrown against the coastline, causing more material to be broken off. Whereas attrition is when materials such as rocks and stones are carried by waves, but then are hit and knocked against each other, wearing themselves down. The effects of attrition are also amplified when the waves carry material farther and longer. So a large round boulder would be gradually reduced into round sand grains or quartz the longer it remains in the ocean and the farther it travels along the shore. Lastly, we have corrosion. Now, this refers to the chemical erosion of rocks, where weak acids in seawater dissolve and break down the rock minerals, particularly calcium carbonate-based rocks like limestone and cork. Another important marine process is marine transportation, where the sea transports sediment that it gets from erosion in the same way that rivers do. Now, the materials in the sea arrive from many sources. The first one is it could be eroded from cliffs. It could also have been brought inland from offshore by constructive waves, meaning that the waves would have brought sediment or particles from the deep sea onto the shallower waters. It can then also be carried to the coastline by rivers. So rivers can transport different sediments and materials down the river all the way to the river mouth, where it then gets transported into the ocean. And then lastly, it can also be transported by longshore drift along the coastline. Now, longshore drift is the main process of transportation along the coastline. The waves approach the beach at an angle, and this is because of the wind. So the wind would kind of push the waves at an angle when it hits the beach. So as the waves break, the swash then carries material up the beach at the same angle that the waves came at the beach. As the swash dies away, the backwash then carries the material down the beach at an angle of 90 degrees as seen here. So the process then repeats and the material is transported along the beach kind of in a zigzag movement. Now the beach sediment is carried further down the coast where longshore drift is one way. If it is blocked, sediment cannot move and the area further down the coast is deprived of sediment. This results in two problems. Firstly, smaller beaches are less attractive to tourists, causing a loss of income. And then it also removes natural coastal protection because it creates a shorter, smaller beach. Now, once the sediment and materials are in the water, the materials moved in different ways. The first is through traction. So large particles like boulders or pebbles are rolled along the riverbed or seabed by force of the water. This usually happens in high energy environments, such as fast flowing waves. We then have saltation. This has to do with smaller particles like sand and gravel. They are bounced or hopped along the seabed. The particles are lifted temporarily and then dropped back down due to the water's movement. Now, this occurs in areas with medium energy, such as moderate flow waves that already crashed and broke onto the shore. Then we have suspension, and this has to do with very fine particles, such as silt and clay. Now they are carried along the water without touching the bed. These particles are suspended within the water column and can be carried over a long distance. Now this is common in low energy environments. Lastly, we have solution. Now this is for dissolved materials, and especially minerals like calcium, magnesium, and sodium, which are transported with the water as chemical ions. So these materials dissolve into the water and cannot be seen with the naked eye. Now it occurs in all types of flow as the materials are dissolved and not visible. They're commonly in areas where water interact with limestone or cork, which dissolves easily. So the last ocean process that we would have to have a look at today is marine deposition. So if we imagine a shoreline with water at its low water mark, we can look at the different deposition. So we know that waves carry sand and shingles as they travel. So the swash will carry these material onto the shore, whereas the backwash would carry it away from the shore and deposit it back into the ocean. Now we're going to have a look and discuss this in terms of a constructive wave. So the largest material will be deposited along the upper reach of the swash when the constructive wave carries the sediment up the beach. Now the backwash will lose water and energy as it travels back because of the sand's porosity. This will result in smaller and smaller deposits. So if we have large deposits at the top, we'll have shingles below it, coarse sand below that, and fine sand even lower. Now when the constructive wave carries sediment up the beach, the largest material is deposited along the upper reach of the swash. Now even during a storm, large shingles or even maybe boulders are thrown above the usual high tide level to form a ridge at the top, and this is called the berm.